All right, so this is a talk about pRPC, something that we wrote in order to run basic gRPC services on AppEngine. This is a talk structure. I'll start with like a short overview of gRPC. Then I'll talk about pRPC, and I'll demonstrate it. So most of the talk will be demo. Now, so what is gRPC? gRPC is a new Google standard for RPCs. It's a next generation Stubby. Stubby was being used for 10 years inside Google, except it's not open source, so outside Googlers that are not inside Google Tree could not use it, and the industry is not using it, obviously. So they decided to write a new thing called gRPC. It will Stubby will be surpassed by gRPC. I know many internal teams already use gRPC. So it supports all these 4 languages. It's based on HTTP 2, which is a good thing. It means that it's fast because, for instance, the same TCP connection can handle many requests and responses. It sends messages in binary format, just like Stubby. Which means you don't have to spend time on JSON formatting and parsing. I think protobuf parsing and formatting is faster than JSON, and obviously the size of data being sent is less too. What also, besides unary basic methods, like you send a request and then you receive a response, HTTP 2 allowed gRPC to implement streaming, which means that, for example, a service can return many messages in the same method, one after another, asynchronously, and also to support duplex requests. Finally, gRPC standardizes some response codes. They are separate from HTTP status codes, and they include, for instance, not found, already exists, and so on. So they are standard, and applications can use them, and they're properly documented. The idea of gRPC is really nice. It's protobuf that we all know and love. The nice thing about it is, in contrast to endpoints, for instance, is that it does not have any language, any implementation details, and it can be documented. Which is great because if you use endpoints before and someone asks you, like, what is your API, you gave this person a location of your source code, and he had to parse it, and which can be challenging. So protobuf is nice. It is declarative too. This talk is going to be focused on Go because pRPC supports only Go, at least for now. So when you compile a protobuf file to Go, you get an 2 interfaces per service. Here we had a service called greeter. It has one method called say hello. It's a unary method. It accepts one request, one message, hello request, and returns one hello reply. And this definition is actually taken from gRPC Hello World app. And this is a Go interface that is going to be generated from that protobuf. For each service, there will be 2 interfaces, one for server and one for client. They look similar, but a little bit different. Like, this is a difference. And in order to implement a gRPC server, you just implement this interface, like this. This is implementation of the greeter service. It accepts hello requests, it returns hello reply. If name is not specified, it returns the gRPC error with code invalid argument. And if name is there, it just returns the hello reply message. So as you can see, thanks to this generated interfaces and messages, it's quite easy to write this kind of code. And the client code looks simple too. Here you somehow create the instance of the greeter client interface, and then you just call this method. You specify the request message, and you receive the response message or perhaps an error. So gRPC is great. We all want to use it, but at this time we cannot use it because we had some issues with it. gRPC is heavily based on HTTP2. It does not support HTTP1, and AppEngine currently does not support HTTP2, which prevents us from using gRPC on Classic AppEngine today. But gRPC team told me that they actively working on it, and they will fix this issue by the end of the next quarter, I think. There's no way currently to send a request from JavaScript to gRPC servers because gRPC uses trailers. HTTP trailer is like HTTP header, but it goes after the body. So browsers do not support it. That's my understanding, but I may be wrong. But the bottom line is that you cannot send a request from browser.
Wait, really quickly, Nadir, are trailers required to understand gRPC protocol? I thought they were semi-optional, like you could put stuff in them, but
I think that's how they return codes or something.
Oh, really?
But
okay.
I know that there's currently it's not supported. Maybe that's a wrong reason, but it's not supported as of now.
Interesting.
Okay. But it also doesn't support JSON encoding either, right?
Yeah, that's true also. Okay. I think so.
Didn't last time.
It doesn't.
Yeah, well, last time we checked, maybe like yesterday it changed, maybe. I don't know. Also, last time I checked, it didn't have auth 2 support on the server side. So, for instance, you cannot, even if you specify the authorization HTTP header in the request, on the server you cannot actually check it. There's no place to put this hook to check the HTTP header. And finally, if you use Cloud endpoints, you may be used to API Explorer, which looks like this. If you don't know, it allows you to discover methods and call them. So currently there is no such a thing in gRPC. So we had this kind of dilemma. I hope this is not too harsh. Our team used endpoints for Go, but wrote a lot of workarounds around it. So we came to the point where we wanted to use gRPC very much, but we could not. So this is how pRPC project was born, where first P stands for provisional. I'll explain it in a bit. So if you want to remember just one thing from this presentation, this is what you want to remember, is that you write gRPC code and pRPC runs it on AppEngine. That's it. If you don't have time, you can go.
TLDR.
All right, so this is TLDR of this presentation. And so the provisional here means that once all those gRPC issues are solved, our requirements, we'll just switch to gRPC. So pRPC is indeed provisional. So what is pRPC? First of all, it is as much. It is compatible with gRPC code as much as possible. It's the same IDL, same protobus, same service and client interfaces. The wire protocol is based on HTTP1, which allows us to host it on AppEngine. It works in browser, does not use trailers. It supports binary, JSON, and text protobuf formats, so you can send JSON, for instance. We added a hook to implement the OAuth 2 server on the server side, and LucyGo repo implements the actual hook. It does not support streaming or duplex because HTTP1, but we support unary, and so far it's enough for us. And also we wrote a tool called cproto. It's a wrapper around proto-C, which after generating the Go code from proto file, it slightly modifies the generated code in a backward compatible way, just adds some functions and mutates some existing ones, but in a backward compatible way, in order to support pRPC and some extra stuff that's listed here. In particular, discovery. We implemented discovery for our services. We wrote RPC Explorer, which is like an API Explorer but better, and also CLI tool, which is like stubby tool if you're familiar with it, but also nice. So from this point, I'm gonna just demonstrate it. I decided to go not with Hello World app, but BuildBot, because we all know how BuildBot looks like, or at least its concepts. So here I have a service called BuildBot. It has two methods: search and schedule. The search accepts search requests, returns search response, and schedule accepts search schedule requests and returns schedule response. So search request has master state, which is an enumeration, is here, and the builder, and it just returns a bunch of builds, many builds. And schedule is similar. I'll not go into details, but I'll demonstrate it later. Okay. So here I have generate file. This is a Go generate that just runs cproto in the same directory. So cproto, as I said, it's a tool. It's our wrapper around proto-C. As you can see, it has very nice CLI, no arguments by default. The defaults are same. It just finds all the proto files in this directory and compiles them to Go, and also slightly modifies them. So this is a file it generates. Most of the contents of this file is the same as you would use proto-C with gRPC plugin as like a standard, except the register function, instead of accepting star gRPC server, it accepts pRPC register, which is compatible with gRPC server thanks to the way Go interfaces work. So gRPC server, star gRPC server actually implements pRPC register. And also we generate the new a function to generate a client. So usually with gRPC there is a new client, new BuildBot client functions generated, which returns BuildBot client and accepts gRPC client connection. And we generate new BuildBot pRPC client function, which returns the same interface but accepts different parameters. So this was protobuf compilation. Now, if we go here, this is how we host. No, wait a second. This is implementation of the BuildBot service. Of course, it's a fake implementation. This is a list of all builds. Search accepts the search request, returns search response. The implementation is not important here. The fact that it's easy to implement, the signature is important. Now, finally, let's host this service. We create a pRPC server. We register the service. We enable discovery. I'll talk about this in a bit. And we just install standard HTTP handlers. Well, this is a HTTP router, but it implements HTTP handler. So it's easy to integrate if you don't use LucyGo at all. And this is not LucyGo specific. So I have a dev server running here. I guess here, yeah. So I'm gonna, I have this BuildBot service running, and I'm gonna curl it. So pRPC services are hosted, handlers are hosted at /pRPC/service name /method name. And these are just basic HTTP1 post requests. So I can just make a curl request, a post request, specify the method, specify that I want it to be returned in text format. It will print it just like stubby. If I don't specify it, like I can specify JSON too, but it's hard to read. That's why I use text. We could also try to use curl to specify the request message, but it's kind of hard. So I'm going to use the RPC tool that we wrote. RPC tool is like stubby tool. You can specify the host name the full method name, and it just returns the same thing. But it also allows you to say state success, specify request fields as flags, or you can, if you have a JSON request, you can just echo, pipe it into the STDN too. So RPC tool allows you to call, is a CLI tool that allows you to call pRPC services. Right. Here's another example. Let's try to make a let's try to make a request from a Go code. Here I create the client. I specify the I'll specify 8080 here. I make a request message. I accepted the builder name from the argument, from the fields, from the arguments. I call the search function on the service. If there's an error, I just print it to str, and otherwise I just print the builds. So let's try it. Client. I guess I should not change this.
Did it reload the dev app server?
I think, what?
It might have reloaded the dev app server when you changed the code.
Oh,
yeah.
Maybe, I don't know. So I demonstrating this in a wrong order, but anyway, I also run the same server on the AppEngine, the real AppEngine, and it just printed the builds on that AppEngine app. So I can specify, for instance, the builder name, and now it filters by builder name. So, right. So RPC call would also work. RPC call would also work if I specify pRPC talk. This is an app that I uploaded for this talk. So this works. As you can see, the CLI works. You can also make requests from Go code, which is really the important part. Do you have any questions so far? Okay, cool. So now it's time for discovery.
One question. The cproto tool and the RPC tool are Go binaries compiled from LucyGo, or where do they live?
They live in LucyGo, and yes, they're compiled from Go. Right, and if we ever write pRPC for like Python, RPC tool will be the same. We'll not have to rewrite it. So now it's time for discovery. So the cproto tool, what it also does, besides having a nice interface, is that it also generates this pp.discovery.go file that for each service that we have in proto files, it dumps this description in byte format, which allows us to do things like this. If we the show subcommand, you specify the host name, and it shows the list of services available on that host name. If we specify, say, the name of the service, it prints the service definition in product format with a list of methods and documentation, which is important. If we specify, for instance, the full method name, it prints the same thing, but with just one method, and with input and output requests. You can also specify, for instance, buildbot, search, request, and it will print the definition of the message.
So you could say like buildbot build to get the definition of what that repeated build object was, right?
What?
On the search response, it says repeated build. So you might want to see what that object is, that message type is. So buildbot build would work.
Search response and what?
Builds. Well, that's the field. I was talking about the message type. So if you look at the response, it says repeated build. But to get help on that build, you'd say build.build, right?
No, I just don't have documentation on builds.
Oh, I see.
If I had it, it would be printed. It would be printed
But the
here.
build message itself is.
Oh, you mean build? Sorry, yes.
Yeah.
Yeah, if you want to go build. Oh, this was unexpected. Oh yeah, I don't. Okay. So I didn't want to demonstrate it. That's why I didn't wrote any documentation.
No, but you can get. I was just.
Yes. Exactly. That's right. So if you want to see documentation of a nested field of a specific message you can just specify the full name of the type, and it will display it with all the documentation.
So it works for AppEngine?
Yes, it will work on AppEngine. If I do the same with pRPC talk, like apps.com, it will do the same thing.
Can you talk really quickly about where it's getting the information for the discovery duck from?
Yeah. I talked about.
Sorry, answer his question first.
Okay, so right, good point. So this discovery document contains all the bytes that describes the service and methods and messages and all the transitive dependencies. And here in frontend in pRPC Go, I had the discovery enabled the server. This is a magic thing, but if you go inside, you will see it's not magic. So it just takes all the services that we registered here. It retrieves the description that we generated, in this file, that we registered here. And, okay. If we actually go here, it's quite easy. So discovery, maybe I should explain this way. Discovery is just a service that I expose. It's just a service with a method called describe, and it returns the describe response, which contains a list of services and a file. I mean, if you're familiar with protobuf descriptions, it returns a message that contains all the services, all the messages with all the leading comments, and all documentation.
I suppose that was my question. Where does it get this file descriptor sets from?
It's generated by the proto.
Yeah, I already said that.
Oh, okay.
You mean that, right? You mean this?
Yeah, that is a serialized file descriptor set?
Yeah, from cproto. When cproto runs, it also generates this file.
The generated stuff that it produces, it looks like when you're running RPC show, the only time the lowercase buildbot dot prefix is ever shown is the top level RPC show. As soon as you start looking at other methods and looking at types and stuff like that, you just have to intuitively know that you should be prepending all of the methods and all of the types with the buildbot prefix.
It's the proto package name. That's how proto messages work. They have a package name.
But the documentation which is being returned by the Discovery API only once tells you what that prefix is.
Because those are the valid proto.
That's unfortunate.
I mean, otherwise it would be invalid proto. Like you could render it with a buildbot dot prefix, but then it wouldn't be valid proto anymore. Is that what you're saying?
It may be ambiguous because if you don't specify the package name, it will not find it.
Yeah, but it could print package buildbot at the top of every single one of its responses.
Oh, that would be incorrect proto. That would be a malformed protobuf.
Then as a comment.
Oh, as a comment.
Yeah, something like that. Just like I was watching you type around in RPC show, and I realized that it takes some knowledge to know that, you type RPC show buildbot.build, and it says, or buildbot.search response, and it says there's a message called builds, and you're like, okay, RPC show build, and that doesn't work, right?
Yeah, so in the past I printed package name before a message, but then I stripped it because it's obvious. I mean, it's not obvious, but once you know it, you probably it will just clutter.
I mean, you basically can't do anything else in proto without understanding that. So, like, It's the same way that we don't print namespaces for methods in Python documentation at every call site either.
But you have the package name. You have the
You
name of the
right there.
namespace at the top.
It's right there. You said build.get.
You have to know the package name in order to get the information in the first place.
Sure.
But if we want, I mean, we can file a bug and say feature
It's
request.
just so, to be fair, the stubby tool does basically exactly the same thing, so I can't complain that much. But this has actually been a long-standing gripe of mine for 3 years using the stubby tool, that it doesn't actually print the full name that you want to copy-paste in order to get more information about that object, right? The way that people use this tool to explore an API is they're like, oh, that's the name of the thing that I want more information about. Let me get more info on that. And they can't just copy paste it from the output because it's not fully qualified. So if we could fix that, that would be cool. Anyway, please continue your talk.
Okay, I'll take this into account. So discovery is what allows us to specify request fields like flags here. It actually, so the RPC call actually knows the type of the state and is able to parse it. So, for instance, right now I don't think it sent requests because it could not parse it. Or if I specify something, it will not find the state, that field. But you can of course also specify the request as a JSON blob or text blob or binary blob if you want to.
Is there auto-completion on command line?
On command line, no. Which is a hint that there is auto-completion, a different thing. So let's
It
go.
has enough information that we could implement auto-completion.
Yeah. So most of our Lucy apps have this /RPC Explorer thing that allows you to explore API. It just lists all the services with documentation. Let's go search and make a request. It returns something. Now, so okay, the API Explorer looks like this. Like if you do put batch, and this is how you are supposed to explore API and specify requests, which may be slow because this combo boxes with this thing, and you cannot paste. Well, you can switch to freeform, which is plain JSON, but it does not support. I mean, you don't have any help. There's like it does not show any documentation. It doesn't show what fields are there and so on. So we decided to combine these two into a text editor with syntax highlighting with auto-completion. So if I press control space, it shows me the list of fields of the request message, names on the left and type on the right, and here we have documentation. Oops. If I go, it shows documentation for different fields.
Nice. Pretty cool.
It also supports enumeration values like this, so I can search for by pending. Finally, if it also supports, if I go inside. Oh, by the way, so this is a scheduling a build. It has builds field, which is a repeated field. Oh, can you see it? You probably cannot see it.
Oh, that's good.
That's good.
Yeah, so the builds field, it shows that it is repeated, and it's a type build def. So it automatically puts this brackets and braces, and now it shows auto-completion for the build def message. So I can specify like release. Also need to specify a master X. And here is my builds. I just scheduled some builds. Yeah, so as you can see, it can be very fast in printing. You can specify, you can write a request much faster than this thing.
Did you write that editor yourself?
Huh?
Did you write that editor yourself?
No, of course I didn't write editor. This is an ACE editor from Cloud9. It's a cloud ID, but I just plugged in the autocompletion based on the discovery document.
Hey, Nadir, could you write like cider for get on board?
I thought no. I've worked. This editor is the same thing that I tried using.
Could you
Yeah, this is a really nice editor.
Also, get on board kind of has a cider, but
Right, actually, it does.
It's not very.
So it is nice. It allows you to type the request fast. So this is a main portion of my talk. There are some extra tools. For instance, cloud endpoints support versions, different versions per service. And Robbie wanted this feature, so we wrote an SVC, a tool for that. So if I go to proto and do svcmux, type buildbot, buildbot server. Okay, so I got this mux, which implements the buildbot service, but it also has default version and a map of a version name to different implementation. So when request comes, it checks this header, HTTP header. If it's present, it takes that version of the implementation. Otherwise, it defaults to it falls back to the default version. And another thing that we wanted is svcdec. svcdec thing generates a decorated service. So it also implements the service, but in every function before calling the actual implementation of the service, it calls this prelude function. So you can decorate your function, your services. For instance, this could check authorization, so we can separate authorization from main implementation of the service.
Nadir, just curious. Am I correct in saying that the DEC, the MUX, and the discovery are all compatible with gRPC if we plug them in?
Yes, exactly. I forgot. One of the reasons these tools are separate, well, besides having one thing doing one thing is good, is that it's compatible with gRPC. It's not gRPC specific at all. And another thing that you reminded me is that RPC Explorer and RPC tool will support gRPC when we switch gRPC. So these extras will not be lost when we switch.
So the only tool that is specific to gRPC with the cproto additions to about the pRPC, right?
Yes, and we can. We'll probably continue using cproto because it's nice CLI and because it generates discovery document.
Mm-hmm.
But we'll just not generate this extra things.
The proto-C command line arguments are pretty horrible in a document.
Yeah, for instance, if you like, this is I omitted this, but we have time. If you want to import a proto file from another directory, you have to specify its import path on the command line. So what we did is that if we want to import another proto file in a different directory, we specify the Go style absolute path. For instance, GitHub/user/repo/path to the product. And we just include the Go path /src when we call the proto-C tool. It also generates correct Go file, with a correct import statement. And finally, one thing I want to show is logdog uses RPC Explorer. So if you want to explore logdog, you just go here, and this is query method. It just returns a bunch of logs, right?
Yep, log streams.
Log streams. So we can just take, for instance, this one to get path, and we get the logs. So my point here is that I guess Lucy services will have this RPC Explorer, and it will be hopefully it will be easy for others to explore Lucy services and call them like that, like this. Do you have any other questions?
I have one. On the AppEngine side, what do you need to do to support pRPC?
Basically, the only thing is that just this code shown. Well, so how Go on AppEngine works is that you just register HTTP header in the default mux. Well, that's like one of the ways. And so the code actually here. But I have this init function. I create a router. I install this is where I install the pRPC services, and then I tell the default mux that everything will be handled by router. And
so I understand correctly, this also adds OAuth to support.
So the OAuth support is done by Magic. So here we have this package. If I open it, it has pRPC file. Which registers this default authenticator, which uses OAuth with email scope for authentication. So if you just import this package, I can send a link to this package later, and our Hello World app just imports that. Once you do that, you automatically get OAuth 2 check on the server side.
So it makes OAuth mandatory, not optional.
It does the check automatically. Your handler still needs to look and see what the authenticated user is to decide what to do.
If you don't specify that header, it will be anonymous.
Okay, so just get anonymous user.
Yeah, and in the service, like Robbie said, you're supposed to check the current identity,
which is something you might consider using that decorator method for, like checking. Like if you had an admin interface, you could assert that every single method has the admin calling it in that manner.
I forgot to say you can sign in like this, just like an API Explorer.
And one will not with Python support. So there is no Python in client, guess no Python on the server either.
So far, we did not implement this for Python.
Are you planning to do it, or you will let somebody else do it?
Well, I don't mind if somebody else do it. Most of the tools will still be. I mean, the RPC Explorer is just static HTML. It's not specific to language. The cproto is specific to language. The extra tools that we wrote, like svcdec, they are specific
to Go.
To Go.
The Python version of those would probably look different anyway. So
yeah, it would look different.
They're code generators.
Right, RPC tool will remain the same if we implement this for Python. Because so the protocol, the pRPC protocol is actually properly documented, so it is here. I can send a link later. This is a protocol, it's documented. If Python implements the protocol, you have pRPC for Python.
Are there plans for like Lucy config or some other central AppEngine app to have like a meta discovery service saying these are the AppEngine apps Chrome infra runs which expose pRPC interfaces?
Right now, I don't know.
I mean, we could. We have enough information in Lucy config to know where all the services live. We could have a page that shows where all of the different explorers for all the services are.
Yeah.
And in answer to your question about C++, yes. C++ doesn't run on AppEngine, and so you can just use stock gRPC.
You don't have to use pRPC with C++. You can just use vanilla gRPC
or Java.
But if you wanted all these features, you would have to use pRPC, because right now gRPC doesn't have text or JSON methods of talking to it. You can only use binary.
That is true.
And RPC Explorer only does JSON.
Yeah, so the current gRPC stock implementation gets you. I think the RPC tool would still work because it can talk. We could make it talk binary over HTTP2.
We'd have to tell it, but yeah, at that point
that would be pretty easy. The RPC Explorer relies on JSON, which gRPC server side doesn't support it.
So how's gRPC support for authentication on AppEngine?
Well, gRPC doesn't work on that, which is why we wrote gRPC.
Okay, so I'm confused. I thought you just said that C++ support for this was available for gRPC.
It is, but not on AppEngine. You can't run C++ on AppEngine at all.
So, except as managed.
Okay, so that's my only use case I was concerned about was running on AppEngine.
On C++?
Yes.
Can you run C++ on Engine?
You just can. I mean, it's not even gRPC
Classic
problem.
doesn't support C++.
We're talking about AppEngine v1, by the way. Like,
Yeah, you can run C++ on like managed VMs, which are almost AppEngine, but you cannot just upload C++ code and have AppEngine manage it for you like you can with Python or Go.
I see.
So with managed VMs, I think you can use gRPC on managed VMs, but you can only use unary.
You can use gRPC internally to communicate out from managed VMs, but you can't host it so that GFE won't forward.
Even on a managed VM? I think on a managed VM.
Oh, did they fix that?
I think you can.
They might have fixed that.
I think you can send gRPC to a managed VM.
Oh, it'll demux it as HTTP.
It'll
That's
turn
right.
it in the middle. The GFE will turn it into HTTP1, and your.
But I think the problem is your HTTP2 server won't accept the HTTP request.
It doesn't have.
Sure.
Yeah, because
Oh,
it just goes.
okay.
Like you don't have explicit HTTP.
That's,
No.
will it negotiate errors?
Yeah.
Okay, cool.
But yeah, it doesn't have discovery requests.
I have another question. If I remember correctly, gRPC has by default monitoring and kind of data collection. Is
Yes.
there anything like this
No.
in pRPC?
No. So yeah, gRPC, that's true. gRPC will already have monitoring and some extra stuff. gRPC does not have that yet.
The basic library is endpoints has monitoring. The gRPC library, I don't think has a monitoring channel for that.
I think it does. It has like a callback interface.
Oh, it has
to
a
the-
callback.
And
Yeah, I
keeps
think
metrics.
gRPC website says it will support monitoring, and it's not specific to Clone. I mean, you can run gRPC non-AppEngine and still have monitoring.
But TSMon Go lives adjacent to pRPC in LucyGo, so we could easily like add default metrics to the pRPC generated client using Go TSMon.
I think it would just be a library change, right? For collecting stats.
Yeah, I can add a hook for monitoring. Actually, Prelude can do that. But anyway, yeah, we can add a hook. It's actually already. So when you install a handler or this, it accepts a base which can do whatever it wants with a handler. It accepts a handler and returns a handler, so it's a decorator.
Oh
So-
yeah, perfect.
We could add monitoring right there.
Yep.
We have only 5 minutes left, so I just say that. So the summary is, you can run gRPC code on GAE. It has discovery, it has RPC Explorer and COI tool. Well, I guess that's it. Maybe some other questions. If I... Can you stop recording?